All right, so I'm going to go over your test review in preparation for your upcoming test on Monday. Now, you'll have questions that ask to find coterminal angles in both degrees and radians. To find a coterminal angle in degrees, you add or subtract 360, right? That's how many degrees are in a full circle, a full rotation. With radians, you can add or subtract 2 pi, right? 2 pi is a full circle, full rotation, all right? Now, you'll, again, have questions that we might ask you to find a positive and negative coterminal angle, and we might ask you just to state the quadrant of the angle, right? Either way, right, they should be doable with the same steps, right? So finding the quadrant in which 115 lies, I would draw a coordinate plane, right? I would always do that for these kinds of problems. I know that 0 is here, 90 forms this right angle, 180 is the straight line, 270 goes a little bit more, and then 360 is all the way around, right? And then 115 is between 90 and 180, so that's going to be this line right here, right? Somewhere right there. It doesn't need to be exact, right? But I know it's going to be somewhere right there, and that's in the second quadrant, right? So for this one, I would say quadrant 2. All right, now to find a positive and negative coterminal, I can add or subtract 360. All right, I already have a positive, so I'm going to see what happens when I subtract. All right, let's subtract 360. This should get us negative 245, right? And that's a valid negative coterminal angle. All right, and now to find a positive coterminal angle, we just found a negative. Let's add to 115. All right, if I add 360 to 115, that gets us 475, which is a valid coterminal angle. All right, let's do the same thing with the next one, right? I don't know exactly what quadrant this is going to lie in, right? So what I'm going to do first, I'm going to first find coterminal angles and then see if that makes it a little bit easier to determine the quadrant that it's in. All right, so first I'm going to add 360, right? It's negative already, so I'm going to add just to make it, just to get us somewhere a little bit closer to a positive. All right, and if we add 360 to this, that's going to get us negative 260. All right, that's a valid negative coterminal angle, right? That's fine. To find a positive coterminal angle, I can add 360 again, right, to what we just found. Right, that just makes it 2 full rotations from where we originally started. All right, so that's 2 full rotations, and that's going to get us 100 degrees. And that's a valid positive coterminal angle, right? And then now to find the quadrant that it's in, I know where 100 is on the coordinate plane, right? I know that this is 0, 90, and 180. I know 100 is between 90 and 180, so it's going to be somewhere right there, right? So this is our angle, and I know that it's in the second quadrant. All right, we can do the same thing with the next one. 1005 is already a positive number. It's a pretty big positive number, so I'm going to try to subtract to see if that gets us something a little bit closer to something a little bit closer to what we want, right? We want a positive and a negative. So let's subtract 360. All right, that should get us 645. All right, that's a valid positive coterminal angle, right? That's fine. Let's subtract again. Let's see what that gets us. And that gets us 285. Right, which is another valid angle that works, but we already have a positive one. And I want to find a negative one. So I'm going to subtract 360 from this. Right, and if you take away 360 from 285, that gets you negative 75. Right, and that's a valid angle. All right, now to find out the quadrant that it's in, I would use the angle, the coterminal angle that I know fits between our 0 to 360 range. So I have a 0, 90, 180, 270, and 360. Right, this 285 is the one that fits between angles that we see on here, right? I know that 270 and 360 is what's going to capture that 285. Right, so that's going to be in quadrant 4. All right, now 6, 7, and 8 are all in radians, right? And you can tell that they're in radians because you don't see a degree symbol. All right, so adding or subtracting 2 pi this time is how we're going to find our coterminal angles, right? So I'm going to add 2 pi here. All right, now the only thing to keep in mind with radians is you don't want to add 2 pi. It's just the way it's written, right? I need to make sure I have a common denominator, right? So I'm going to take this 2 pi, write it over 1, and then multiply the top and the bottom by a common denominator, which is 4. And that gets us 3 pi over 4 plus 8 pi over 4, and that gets you 11 pi over 4. And that's a valid positive coterminal angle, right? We just found a positive, so let's try to find a negative, right? So I'm going to do 3 pi over 4 minus 2 pi, all right? And once again, I need a common denominator, so I'm going to write this over 1, multiply the top and the bottom by 4, and then I get 3 pi over 4 minus 8 pi over 4. All right, and that's going to get us negative 5 pi over 4. All right. Now to find out the quadrant that it's in, there's a way to do it in radians, right? So there's a way to label the coordinate plane as you do in degrees, but in radians. But I think for you guys, it's easier to first convert our angle to radians and see if that gets us something that falls in our 0 to 360 range, right? In degrees, right? You guys are more comfortable working in degrees. So I'm going to take my original angle, 3 pi over 4, and I'm going to convert it to degrees. I covered this on the next page or on the next set of problems, right? Which I can scroll down to, right? So to go from degrees to radians, the conversion factor was pi over 180, right? And then to go from radians to degrees, it was 180 over pi. All right. So if we want to go from radians to degrees, I would do times 180 over pi, and then your pi cancels out, and then we get 3 times 180 divided by 4, and you guys get a calculator, so this is going to get you 135, right? And then that's something that fits in our coordinate plane, right? If I were to draw that, right, 0, 90, 180, right? That's going to be between 90 and 180, right? That's quadrant 2. All right. We can do the same thing here. Negative 7 pi over 6, I can add or subtract 2 pi. It's already negative. Let's see what happens when we add. So if I do plus 2 pi, again, I want to write that over 1 and then multiply the top and the bottom by a common denominator. And that's going to get us negative 7 pi over 6 plus 12 pi over 6. And then from here, you can just add straight across, right? So negative 7 pi plus 12 pi is going to get you 5 pi over 6. And that is a valid positive coterminal angle, right? To find a negative coterminal angle, I'm going to take my original negative angle and I'm going to take away 2 pi. So minus 2 pi, again, write that over 1 and then find a common denominator. So multiply the top and the bottom by 6. And then we get negative 7 pi over 6 minus 12 pi over 6 equals negative 19 pi over 6. All right, and then to find out the quadrant that it's in, right, I can take my angle. It doesn't really matter which one. I'll use the original 7 pi over 6, the negative 7 pi over 6, and I'm going to convert it to degrees, right? And again, to do that, it's going to be times 180 over pi. And then our pi's cancel out, and then we can do negative 7 times 180 divided by 6. Right, and you guys get calculators. This is going to get you negative 210, right? But once again, in the coordinate plane, it's easier to work with positive numbers, right? I did show you guys in the very first lesson of this chapter how you would label the coordinate plane if it was negative. You would do the same thing that we've been doing with our original, right? So up here, right, you would just go clockwise instead. Right, but if you want to keep it consistent, do the same thing every time, you can just add 360 and you get 150, right? And then you can draw the angle from there, right? So 0, 90, 180. Once again, I can stop right there because I know 150 is between 90 and 180, right? And that's in quadrant 2. All right, do the same thing with the last one. 17 pi over 4 to find a negative coterminal angle, and positive one, I can take away 2 pi. So I'm going to minus 2 pi, find a common denominator of 4, and then you get 17 pi over 4 minus 8 pi over 4. And then 17 pi minus 8 pi is going to get you 9 pi over 4, and then that's a valid positive coterminal angle. Right, to find a negative one, right, I already started positive, I ended up with a positive, I'm going to take away 2 pi again. So subtract 2 pi, find a common denominator. All right, that gets us 9 pi over 4 minus 8 pi over 4. And that's going to get us just pi over 4, right? And that's a valid positive one, but again, I want a negative one. So I'm going to take away again, right? I'm going to do pi over 4 minus 2 pi, and then find a common denominator. So then this gets you pi over 4 minus 8 pi over 4, and that's negative 7 pi over 4. And that's a negative coterminal angle, right? And to find the quadrant that it's in, I would take one of our angles and convert it to degrees, right? Pi over 4 seems like the simplest one, so I'm going to convert that one. All right, so you can do pi over 4 times 180 over pi, and then you get 180 over 4, which is 45. All right, so 45 degrees is in the first quadrant, right? Between 0 and 90. All right, so this is in quadrant 1. And converting from between degrees and radians, right, I already established what the formulas were. So let's go ahead and do that with these kinds of problems, right? So converting, I see a 135 degrees, right? There's a degree symbol, so I want to go to radians. So I'm going to do times pi over 180, right? Think of it like if I want the degrees to cancel out, I want that on the bottom, right? And then you end up with 135 pi over 180. And then you can find a common factor, right? You guys get calculators, so keep taking out factors of 135 and 180, and that gets you 3 pi over 4. All right, now negative 7 pi over 4, that's in radians, right? I don't see a degree symbol, so I'm going to convert it to degrees. All right, to convert it to degrees, it's going to be times 180 over pi. And then the pi's cancel out, and then we get negative 7 pi over 4. Negative 7 times 180 over 4. And then once again, you guys get calculators. That should get you negative 315 degrees. All right, doing the same thing with these problems. 5 pi over 3 is in radians. I don't see a degree symbol, so I'm going to use that conversion. I'm going to do times 180 degrees over pi, cancel out pi, and then we get 5 times 180 over 3. And then that gets you 900 over 3, right, so 300 degrees. All right, for negative 510, right, I can multiply by pi over 180. Right, I want to cancel out the degrees, so I want that on the bottom this time. So then you end up with negative 510 pi over 180. And then that's going to get you negative 17 pi over 6, right, if you simplify fully. All right. This next one, pi, I don't see a degree symbol, so it's in radians. Right, so this is going to be times 180 over pi, and then pi's cancel out. You're just left with 180. All right, and then 210 degrees, I can convert that to radians because I see a degree symbol, so I'm going to have pi over 180 degrees, right? Cancel out your degrees, and then you get 210 pi over 180, and then 210 pi over 180 is going to simplify. All right, simplifying that fully, you're going to get 7 pi over 6. All right. The next part of that first lesson that I taught you guys was arc length and sector area. We'll be giving you guys these formulas, the arc length and the sector area formula. But I included it in the review just so that you guys know which one's which, right? So to find the arc length, that's going to get you, or that's going to be S equals R theta, right? S is going to be your arc length. R is the radius of your circle, and then the theta is your angle. And then to find your sector area, that's going to be A equals 1/2 R squared theta, right? R and theta are the same as it was in the previous formula. A is your area. Now your degree, your theta, must be in radians in order to use this formula, right? If you have a problem that gives you the angle in degrees, you need to convert it to radians before you can continue the problem, right? Just like this example here, right? I give you a radius of 15 inches and an angle of 120, right? I can't plug in 120 into S equals r theta and A equals 1/2 r squared theta, right? I have to convert it to radians. So I'm gonna take my 120 times pi over 180, right? And then you get 120 pi over 180, and then that's gonna get you 2 pi over 3 when you fully simplify. All right, so then I would use that in my formula, right? If I want to do S equals r theta, that's gonna get me S equals 15 times 2 pi over 3. That simplifies to 10 pi, which to the nearest tenth, that's going to be 31.4 inches. All right, now to find the sector area, all right, remember that's 1/2 r squared theta. So my area is going to be 1/2 15 squared times 2 pi over 3. All right, and then you can simplify this if you want to, or you can plug it straight into your calculator. This is going to get you 75 pi, which is going to get you about 236.6. I'm sorry, not 236, 235.6 square inches. All right. The next two problems are a little bit easier because I give you the angle already in radians. All right, so my radius is going to be 3. My angle is pi over 4. So I can just plug this straight into S equals r theta. It's going to be S equals 3 times pi over 4. All right, which is going to get you 3 pi over 4, right? Simplified. There's not much you can do there. All right, but to find this as like a decimal approximation, this is going to be about 2.4, right, to the nearest tenth of a meter. All right, and then you can do the same thing with my area formula, right? 1/2 is r squared theta, right? So it's going to be area equals 1/2 3 squared times pi over 4, which is going to get you 9 pi over 8, right? And then 9 pi over 8 is going to be about 3.5 square meters. All right, include your units. All right, and then this last one on this page, again, I have my angle in theta, so I can just plug it straight in. It's going to be S equals r theta, which is S equals 16.5 times 5 pi over 6. All right, I don't want to go through the trouble of trying to simplify this decimal. All right, so you can just plug it straight into your calculator. All right, let's see what that gets you. All right, I got that to about 43.2 centimeters. All right. And then for your sector area, again, same formula as before. It's going to be 1/2 r squared theta. We already have our angle in radians, so it's going to be A equals 1/2 times 16.5 squared times 5 pi over 6. And then once again, I don't really want to go through the trouble of trying to simplify that decimal. Okay, so I'm going to go ahead and plug this into my calculator and then see what that gets you. All right, it's going to get me about 356.4 square centimeters. All right. Let's match the trig function with the correct ratio, right? So the lengthier part of your test is going to involve right triangle trig, right? So I want to find the 6 trig functions, right? These are just ones that you have to know. I know that sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is the reciprocal of sine, right? So that's one thing that you guys should know. So cosecant, secant, and cotangent are new to you guys this year. Cosecant is going to be the reciprocal of sine, right? So, and if sine is opposite over hypotenuse, then it's going to be hypotenuse over opposite, right? And then secant's the reciprocal of cosine. If cosine is adjacent over hypotenuse, then it's going to be hypotenuse over adjacent, right? And then cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is going to be adjacent over opposite, all right? Now to find the 6 trig ratios for any given theta, I have 2 sides of this right triangle. To find the third, you can use Pythagorean theorem, right? So I can do 5 squared plus b squared equals 13 squared, right? 13 is the hypotenuse. Make sure you're labeling these correctly. Right, and you get 25 plus b squared equals 169. And then I want to get b squared by itself. So we get b squared equals 144. And so b equals 12, right? Square root of 144 is 12. All right, and now I'm going to label my sides with respect to my angle theta. This 5 is going to be my opposite. This 12 is going to be my adjacent. And the side across the 90 degrees is going to be my hypotenuse. All right, and now this is all we need to find our 6 trig ratios, right? So I want to find sine, cosine, and tangent. Whoa, hang on. All right, so SOHCAHTOA, that's the easiest one to start with, right? It's going to be 5 over 13, right? So sine is opposite over hypotenuse. Ka, right, cosine is adjacent over hypotenuse. It's going to be 12 over 13. Tangent, TOA, is going to be opposite over adjacent, so 5 over 12. All right, the new ones are going to be cosecant, secant, and cotangent. All right, cosecant is going to be the reciprocal of sine, right? So hypotenuse over opposite, 13 over 5. All right, secant is the reciprocal of cosine, so 13 over 12. And cotangent is the reciprocal of tangent, so 12 over 5. All right, and that's all you need for this problem. All right, the next one. Again, I have 2 sides of this right triangle. I can find the third just by using Pythagorean theorem, right? So 8 squared plus 15 squared equals c squared. And that's going to be 64 plus 225 equals c squared, right? So 289 equals c squared, right? You guys use calculators. C is going to be 17, right? And now I can label each side of my theta with respect to, I can label each side with respect to theta. 8 is going to be my opposite, 15 is my adjacent, 17 is my hypotenuse. So I can do the same thing as before, right? You do SOHCAHTOA to find sine, cosine, and tangent. Right, sine is opposite over hypotenuse, so 8 over 17. Cosine is adjacent over hypotenuse, so 15 over 17. Tangent is opposite over adjacent, so 8 over 15. And then to find my reciprocal ones, right, so cosecant, I know that that's the reciprocal of sine, so 17 over 8. All right, secant is the reciprocal of cosine, so 17 over 15. All right, and then cotangent is 15 over 8. All right, and that's all we needed to answer that problem. All right, so in number 26, there's a couple ways that you could do it. You could use Pythagorean theorem and find the missing side that way. Or you could recognize that this is a 45, 45, 90 triangle, right? So 45, 45, 90 triangles have 2 congruent sides. All right, so if I have a 7 and a 7 square root of 2, then my missing side is 7 as well. All right, so this side has to be 7. All right. If you didn't recognize that, you would use Pythagorean theorem. I would try to avoid that, though, by knowing your special right triangles, which I do expect you guys to know for your test. Right, so if you wanted to use Pythagorean theorem, you could have done 7 squared plus b squared equals 7 square root of 2 squared, right? And then you should know that to square something that's being multiplied, you would distribute to each factor. So it would be 49 plus b squared equals 49 times 2. So 49 plus b squared equals 98. Subtract 49 on both sides. And then we get b squared equals 49. So b equals 7, right? But that was a lot of work for something that we could have just used a special right triangle for. All right, so try to avoid that when you can. But in any case, we should get 7 as our missing side, and we can find opposite, adjacent, and hypotenuse. My opposite is 7. My adjacent is also 7, and my hypotenuse is 7 square root of 2. All right, so I want to start with SOHCAHTOA. All right, so find sine, cosine, and tangent. So sine is going to be opposite over hypotenuse, so 7 over 7 square root of 2. The 7's cancel out, but you still need to simplify because we have a radical on the bottom. So I want to multiply the top and the bottom by the square root of 2 to get rid of that radical on the bottom, and there's your simplified answer for sine. Right, for cosine, same thing, right? My adjacent is 7, my hypotenuse is 7 square root of 2. Again, cancel out your 7's, but you still need to rationalize. So then you get square root of 2 over 2 also as an answer for cosine. Now with tangent, that's opposite over adjacent. My opposite is 7. Adjacent is 7, that just gets you 1. All right, and then to find cosecant, secant, and cotangent, right, I would just take the reciprocals of my answers. All right, so cosecant, you can choose to take the reciprocal of your final answer for sine or the unsimplified one. I'm going to go with the unsimplified one just because if I have 7 square root of 2 over 7, right, which is what I got from this unsimplified answer, all I have to do is cancel out 7's, and I'm just left with square root of 2. All right, same exact thing with secant. I'll show you the other way. If you chose to do the reciprocal of this, right, it would be 2 over square root of 2. You would have to rationalize your denominator, and then you get 2 square root of 2 over 2. But once again, your 2's cancel out, and you're also left with the square root of 2, right? So you get the same thing no matter how you do it. And with cotangent, 7 over 7, the reciprocal of that is going to be the exact same thing. So 7 over 7 is 1. All right. Now let's use that information to fill out this special right triangle. All right. So I know that a 45, 45, 90 is going to have the legs be congruent and the hypotenuse multiplied by the square root of 2. All right. So you can really label this however you want. I know a lot of you put like A, and A radical 2. I like to keep it simple. I just pick 1, and 1 square root of 2, right? As long as what you have is consistent with what the rule is, then that's fine, right? Same thing with 30, 60, 90, right? 30 is my shortest leg. I can call that A. My longer leg is A times the square root of 3. And my hypotenuse is 2 times A, right? But once again, I just use 1 square root of 3, and 2 times 1, right? And you get the same thing, right? So I'm going to use that information to find the 6 trig values of 30, 45, and 60. These are also in your notes, right? So you guys have these exact trig values in your notes if you want to have a look at those as well. All right, and I do that in the lesson video as well. But I'm going to start with sine, cosine, tangent. All right, and then after that, we're going to have to do cosecant, secant, and cotangent. All right, so sine, I'm going to look at the triangle that I drew above. And I know that with respect to my 30-degree angle, the opposite is going to be 1. The adjacent is going to be the square root of 3, and my hypotenuse is going to be 2. Right, so opposite over hypotenuse is going to be 1 over 2. Right, with cosine, my adjacent was the square root of 3. My hypotenuse is still 2, so this is going to be square root of 3 over 2. Right, with tangent, my opposite is 1. My adjacent is the square root of 3, so I get 1 over square root of 3, which you need to rationalize. So you get square root of 3 over 3, which is going to be just that, right? Square root of 3 over 3. All right? And then for secant, cosecant, and cotangent, take the reciprocal of what you got for sine, cosine, and tangent. So for cosecant, we get 2 over 1, which is 2. For secant, we get 2 over square root of 3, which you can rationalize. and that's going to be 2 square root of 3 over 3. All right, and then tangent, I can take the reciprocal of this, and I get cotangent, and it's going to be square root of 3 over 1, right, which is the square root of 3. All right, I can do the same thing with 45. 45 is going to be, all right, so sine, cosine, and tangent. All right, so I know sine is opposite over hypotenuse, which is 1 over square root of 2. But I want to rationalize that. And that's going to give me square root of 2 over 2. Right? Same thing with cosine. That's going to be adjacent over hypotenuse. Rationalize it, and you get the same thing, square root of 2 over 2. Tangent opposite over adjacent is 1 over 1, which is just 1. All right, and then for these, I want to take the reciprocal to find cosecant, secant, and cotangent. All right, so cosecant of 45, I'm going to take the reciprocal of 1 over square root of 2, and that's square root of 2 over 1, which is the square root of 2. All right, for secant, take the reciprocal of 1 over square root of 2, and you get the exact same thing. All right, for cotangent, wait, hang on. Let me try that again. For cotangent, that's going to be the reciprocal of 1 over 1, which is also just 1. All right. Now doing the exact same thing with 60 degrees. All right, sine, cosine, and tangent. All right, I would just do SOHCAHTOA with my 30, 60, 90 triangle. Now my angle of interest is going to be the 60 right here, right? So this is my opposite, adjacent, and then this is still my hypotenuse. All right, so sine of 60 is going to be opposite over hypotenuse. So square root of 3 over 2. Cosine is going to be adjacent over hypotenuse, so 1 over 2. Tangent is opposite over adjacent, so it's going to be square root of 3 over 1, which is just the square root of 3. All right, now to find the reciprocal ones. All right, just take the exact values that you just found and flip them. So it's going to be 2 over square root of 3. Rationalize that denominator, and it's going to be 2 square root of 3 over 3. All right, for secant, all right, take the reciprocal of what you got for cosine. That's 2 over 1, which is 2. And now for tangent, for cotangent, take the reciprocal of tangent, which is going to be 1 over the square root of 3, which you need to rationalize. All right, so hopefully you're noticing that a lot of these values show up a lot. That is going to be the case, right? And in later sections, you're going to see these exact values show up over and over again. All right, so last page on this review, a couple of things I want to go over in this first part of it is finding a reference angle in each quadrant. All right, so in the first quadrant, if I have my angle right here, right, there's nothing really that you need to do to that. The whole point of finding a reference angle is to make a right triangle. And here, whatever angle we have is already going to be part of a right triangle, right? But let's say in the second quadrant, right, I have this angle right here. Right, I know that the initial side is always going to be the positive part of the x-axis, but this part makes more sense in terms of a right triangle. And to find this angle, it's going to be 180 minus my angle theta. Right, now to find this angle right here, this is an angle in the third quadrant. I want to use this angle right here because that makes more sense in terms of a right triangle, and to find that, it's going to be my angle theta minus 180. All right, and then in the fourth quadrant, I can draw a little segment right here. Again, it's easiest to use right triangles, so I'm going to find a reference angle, and to do that in the fourth quadrant, it's going to be 360 minus theta. All right. Other things that I want to make note of in this part are the degrees of a coordinate plane. I know that this is 0, 90, 180, 270, and 360. Another thing I want to make note of are the signs of x and y, right? In the first quadrant, x and y are both positive. In the second, x is negative, y is positive. In the third, both x and y are negative. And in the fourth, x is positive, y is negative. All right, that'll make more sense with our when solving these kinds of problems. Right, so for example, evaluate cosine of 135 degrees. Right, that's not an easy number off the top of your head to be able to do. Right, so what we can do instead is find a coterminal angle. I'm sorry, not a coterminal angle, a reference angle. And in order to do that, I would draw a picture, right? So in any of these problems, I like to draw. So I like to draw the coordinate plane. So I'm going to draw right here 0, 90, 180, 270, and 360. Right, and I know that 135 is going to be between 90 and 180. That's going to be this angle right here. All right, it's going to be something like that. But 135 doesn't really make sense in terms of a right triangle, so we use this leftover space right here. All right, and so a reference angle in quadrant 2 is going to be 180 minus my angle theta. Right, so you know that this whole thing right here, this is a straight line. Right, so I know this little part of it is 135, so to find the leftover, that's another way that you could think of it. Right, so it's going to be 180 minus 135, which is going to get you 45. All right, so this is 45 degrees. We can make a right triangle right here. Right, that's the point of finding a reference angle. And now you guys can see that this is a 45, 45, 90 triangle. Right, and so what I want to do is I want to label my sides appropriately, right? So in a 45, 45, 90 triangle, the sides across the 45 are congruent. So I'm going to label, it's easiest to just use 1, right? Again, you can use any number that you want as long as in the final answer you simplify. So I could say 1 and 1. And then the hypotenuse is going to be 1 times the square root of 2, so square root of 2. All right. Now, another thing to make note of are the signs. I had said that in quadrant 2, x is negative, but y is positive, right? The x value is going to be this horizontal distance, so I'm going to make that negative. And then y is this vertical one, right? So that's going to stay positive. All right, and that's enough information to answer this question, right? To find cosine, I know that that's adjacent over hypotenuse, and my adjacent to this angle 45 is going to be this -1. So it's going to be -1 over the square root of 2. All right, and so I do square root of 2 over 2, which is going to get you negative square root of 2 over 2. All right, and that's your answer for cosine. All right, so these are a little bit more involved. You just need to try a little bit more to get a special right triangle, right? So all of these kinds of questions will get you something in terms of a special right triangle. Hopefully that makes it a little bit easier. All right, so let's do the same thing with tangent of 210. All right, so once again, I would always draw a picture. So I'm going to draw. All right, so 0, 90, 180, 270, and 360. All right. 210, I know that in the coordinate plane, that's going to be between 180 and 270. That's going to be somewhere right here, right? And then this little angle right here, to find this reference angle, right? A reference angle in quadrant 3 is going to be theta minus 180. So that's going to be 210 minus 180. 210 minus 180 is 30, right? So this angle right here is 30. And then that makes more sense with a triangle, right? So a right triangle right here. And then hopefully you guys can see that this is a 30, 60, 90 triangle that we just drew. All right, so I'm going to label the sides appropriately. The side across from the 30 is going to be 1. The side across from the 60, so up here, is going to be the square root of 3. And the hypotenuse is going to be the smallest leg times 2, right? So 2. And in the third quadrant, so in quadrant 3, we know that x and y are both negative, negative, right? So I'm going to change the sign of my vertical direction, which is going to be -1, and then the horizontal one, which is negative square root of 3. Your hypotenuse is never negative, all right? Now tangent, I know that that's opposite over adjacent, my opposite is -1. My adjacent is negative square root of 3. So tangent of 210 is going to be -1 over negative square root of 3. Right? Negative over negative is a positive, and I want to rationalize. All right, so it's going to get me square root of 3 over 3 positive for tangent. All right. Now, sine of 420, that doesn't really fit in the 0 to 360 range. So if I have a 0, 90, 180, 270, and 360, I don't know where 420 is going to be. But you can easily find out that information by finding a coterminal angle, right? So this is where the first page of this review is useful, right? So we didn't just find coterminal angles for no reason. We found it to make problems like these a little bit easier. So you can take away 360, and then you get that sine of 420 is the same as sine of 420 minus 360, which is 60. And I know that 60 is in the first quadrant between 0 and 90, right? So I'm going to draw that right there. I'm going to say this is 60, and I don't need to do anything extra to find my right triangle, right? I know that this angle right here is going to be 30, and then this is a 30, 60, 90 triangle, right? Across the 30 is a 1, across the 60 is a square root of 3, and across my right angle is a 2. All right, and in the first quadrant, everything is positive. So I can very easily say now that sine of 420 is going to be opposite over hypotenuse. And so my opposite is the square root of 3, and my hypotenuse is 2. So it's just going to be square root of 3 over 2. All right. And then lastly, cosecant of negative 210. Once again, I don't really know where that's going to be in my coordinate plane, right? Because I know that I label this as positive numbers in the 0 to 360 range. All right, so to find out where this is going to be, I would add 360 to negative 210. All right, and then we get cosecant of 150. All right, and 150, I know that that's between 90 and 180, so it's going to be somewhere right here. All right, that's 150. And to find the reference angle in quadrant 2, I know that that's 180 minus my theta, right? So it's going to be 180 minus 150, which is 30, right? So this angle right here, this is going to be 30 degrees, all right? And then I know that this is going to make a right triangle, a 30, 60, 90 one, right? So I can label my sides as follows, right? Across the 30 is going to be 1, across the 60 is the square root of 3, and across my across my 90 is going to be 2. All right. I don't know exactly what cosecant is, right? So I don't exactly know what cosecant of negative 210 is going to be using SOHCAHTOA, but hopefully we know that cosecant is the reciprocal of sine. So I can first find sine of negative 210 and just take the reciprocal, right? So sine of negative 210 is going to be opposite over hypotenuse. One thing that I forgot to do was the signs, right? So in quadrant 2, x is negative, y is positive, right? So this square root of 3 is negative, and then this 1 is positive, right? But that doesn't really make a difference in our sine of this function, right? So sine of negative 210, our opposite is 1, and our hypotenuse is 2. All right, so that's sine of negative 210. So then to find cosecant, just take the reciprocal, 2 over 1, right, which is 2. So then I know that cosecant of negative 210 is 2. All right. Those are the hardest kinds of problems that you're going to get. Expect to see maybe one that's going to give you a 30, 60, 90 triangle, and then one with a 45, 45, 90, right? So the special right triangles are super important in this lesson, and you're going to see them even more later on.